All right, so while we're waiting, I would like to take the attendance first. Oh, the weather today is not so nice, right? Thunders. Raining. All right, Chen Genghei, are you here?
Yes.
Okay. Morning. All right, next. The 6A guys, the other three, are you here? No. Gong Junho here, Choi Zhongshan. And who else? Dong Gaoho. Three of you. Okay, good.
何家豪點解你支咪仲係咁細聲
Maybe you have to adjust again.
Told him so many times yesterday in the study group, and his mic was always that soft.
They are very confused. Day 4, right? Day 4. Oh, I'm not get used to why they that mode. Today's stage 15th. Oh, sorry. So I need to do those. Okay, before we proceed. And 陳浩希、張家榮、何展鵬，are you here? "陳浩希、張家榮、何展鵬。Yeah, okay, good. And 林家齊、麥耀南、潘樂之。
Good morning.
Yep. Here for 林家齊、潘樂之 here. 喺度。And 麥耀南 just entered. 蕭俊熙、黃俊熙、鄭群威。
喺度 ，Ben 少喺度。
Yes. 黃俊熙 yeah, 鄭群威。And the 60 guys. 陳子軒、陳龍旺、潘子軒 ，are you here?
陳龍旺喺度。
係陳龍旺。 Feng Zihin here. Now, and Chen Zihin. Do you find Chen Zihin? Not in the group? Chen Zihin, not in the group. Okay, all right. So, wow. So scary. Yeah. Now, and do you know that yesterday I just went to the school and I have got the results of the single mod exam. Now, today, later today, I will try to remind some of you about your performance and what you need to do in the following weeks. I know that you will be busy handling some other subjects, but at the same time, you still need to handle chemistry as well. So as I said before, I just give you weekly quiz and also a weekly essay. And last but not least is the weekly paper one practice. As I said before, paper one is of higher priority, right? If you want to have a practice of that, because it is now raises to about 75% of the total marks in your DSC, okay, after cancellation of SBA. So this is what you have to highly aware of. Now for those, I need to remind you once again, no more procrastinate your MC practice. I found some of you just leave those MC practice alone, even those practice 1 to 7 while we attempting Form 5 leave not yet finished. And no need to mention, we start to have the aim at level 4 practice. It is indeed also an MC practice, and as reflected from the single mod exam, the results are you, and it has already told you yourself something. Okay. And this is what I need to remind all of you. And second is about I've invited some of you who are going to have a paper one practice. Okay, so based on the single mod exam results, I may invite some more to come to join the paper one practice. This is what I'm planning to do. Okay, before I proceed, any volunteers that you want to proceed to greater challenge? But once you have to join that paper one practice, that means every week you have to do it. You have to do one set of paper. No? For the others, you dare not say anything.
No, it's just that we've already joined.
in quotation, is it? In quotation mark?
You mean the word joined?
I don't know. I would, if you have no problem, and just remind you this, what to do this week. First of all, this Wednesday, we have got an essay on bonding and structure. And this Friday, we will have a quiz on the remaining 2 chapters of industrial chem, the later 2 chapters. Okay, what I mean is the industrial process and green chemistry. Okay, and green chemistry, we have got that 2 topic to be tested. So you need to know not only the calculations of the atom economy, but also the definition of atom economy and some principles, right? The 12 principles of green chemistry and how would you apply. And for the industrial process, what you need to do, just to remember, you need to get to know something about 1 carbon chemistry, the equations, the conditions, all should be memorized. Electrolysis of brine, we have got 2 industrial methods, flowing mercury cells, as well as membrane cells. And the third one, what I want to tell you is on the other major industrial process, just like Haber process, content process, right? And in which you have to consider the concept of compromise, okay, between rate and yield, safety, cost, etc. Okay, so that comprises the core elements of your chemistry quiz this Friday. Okay, so you know what to do now. So it's kind of hard about this. I just find someone knocked the door. Oh, there's Shan Ji. All right. Shan Ji, welcome back. And I just mark your attendance first. Now, so for the remaining students, any questions? Any questions? If not, why is it so strange? Because maybe I have opened too many documents and it seems that the computer is so slow. Anyway, now this is unit 52. I have just sent this through WhatsApp. Did you receive it? Do you have it?
I have it opened already.
Is it Lai Wenjing, are you here? Are you in the group today?
I don't.
Alright, so I should have sent this to you as well. Just wait. So for the other students, once you receive it, you may try to have a start on this. All right, that should be this. Okay. Now, we have got the following: separate the use of liquid extraction to do using the separating funnel, and what else? TLC. Second questions, and 3, distinguish. Okay, which one would you like to do first? Warm up. Okay, question 3. Is it gives you a better start of question 3? Whatever啦. Okay, Benzi will be the first one to answer.
講到最尾都係全部做晒㗎啦。
哇，點啊？You may find it difficult. Well, once I said so, that doesn't mean you will finish it. I'll try to take a look on those Google Classroom, especially for some of you. 張家榮、蕭俊熙啊。Oh, you are going to do so, 張家榮? As reflected from your work. I'm the fortune teller. I reminded you many times, right? That you just leave the exercise alone. You have promised me something, right? To do something like daily homework, right? But the reality is not the thing. Okay, Bensil, you'll be doing 3A. Take a look. Suggest a chemical test. You may turn on the mic if you want to. Suggest a chemical test to distinguish funding. So it is a very typical question type, right? One compound from the other in each of following pairs. And our focus today is to check the precise use of words. Okay, I know that most of you have got the answer already, but I need to check the wordings. Bensil.
Wordings 用2,4-dinitrile phenyl hydrazine add 落去
用 that means use to how to use
add a few drops
yes
dinitrile phenyl hydrazine to both solutions.
Add a few drops of, you know how to spell the word 2,4-dinitrile phenyl hydrazine? You know it?
Dinitrile phenyl.
Okay.
You just type it. You just type it in where. That is the key. You just type it in the Google search, right?
唔係我打個 Zoom 嗰個
Okay, you first of all you type it into the Google search engine and something will pop up and you may copy, right? It's a easy, it's much easier. It's much easier, right?
Don't expose me lah, sir.
Okay, so add a few drops of this again. So what's next? That is the method or the test, and you have to give me the observation.
63CO6263 will show red precipitate, and the other will show no observable change.
No observable change. The other one, okay? So why? Why? So what is the use of 2,4-dinitrophenylhydrazine?
To test for the presence of a carbonyl functional group.
Okay, carbonyl group. So this is carbonyl group. So we have got two possibilities of showing carbonyl groups. This one is in form of ketone.
Ah, okay.
Okay, the other one is aldehyde. Okay, so 2,4-dinitrophenylhydrazine, they will both shows the positive results in the ketone and aldehyde. I also see some other students giving an answer, add a few drops of acidified KMNO4 in this solution. So what are you expecting to be observation? Is it possible for the others? Is it possible to add a few drops of acidified KMNO4 in this solution? Ketone cannot further oxidize. So what is the observation? Good start. Yeah.
It should be that the color of the solution that contains the ketone will show no observable change, while that one that contains, if I remember correctly, butane 2-ol, so CH3CHOH, CH2CH3, should have its color change from purple to colorless or pink.
Okay, yes, that's right. So remember, you focus on the purple color. The purple solution is decolorized, right? Because for original color of the organic chemicals is still colorless, okay? Both for ketone and butane 2-ol, they are both colorless. So we talk about the decolorization is to have a focus on the few drops of the KMNO4, okay? That purple solution. So what will happen for ketone? The purple solution still remains, okay? So this is what you need to be pay attention to. While the purple solution is indeed permanganate, right? Indeed, there is an redox. There's a redox. While this is a secondary alcohol, so you may find that secondary alcohol, they will go to what? Under alcohol oxidation to form ketone, right? How about this? They will be showing no reaction. Okay. And would there be the chance of asking you to draw the product of the hydrazone? Would that be a case? Have you ever encountered that one before? If you are asked to draw the product. Yep. But anyone who have got a pen and draw it?
Sorry, Mr. Chin, but
yep.
I remember that the test page and the examination paper will provide me with the structure of the 2,4-dinitrophenylhydrazine.
You want to be given with this one first?
But
I can memorize it?
So I can't memorize it, but I can remember that the hydrazine lost the hydrogen atom and bonded with the carbon atom of the ketone group.
So 2,4-dinitro. So that means it is carbon 1 and then 2,4-dinitro. So this will be this. Okay, so I start from this, the testing agent. Anyone who can draw me the rest? Is it to show the hydrazone, the product? Agree? So we have got CN double bond, is it? CN double bond. What you want to draw is CN double bond. Is it? Oh, sorry. Why? Something like this. CN double bond. And we've got this. Is it correct? And then with R group and an R. And then with represent one is methyl, one is it correct? I just want to double check your understanding. Is it correct? Something has been eliminated. What is that?
Water.
Yes, water. They how many hydrogen and how many oxygen atoms should they be eliminated? So please double check. For a carbonyl group, I have get rid of one oxygen. How about two hydrogen? Yes, that's right. So you have to cross out this hydrogen as well in order to show H2O has been eliminated. It's not just one hydrogen. You have to get rid of two hydrogen. Okay, is that clear? So two hydrogen for the 240 mph. The other O is from ketone. Questions? Now, if not, take a look on B part. Take a look on B part. 張家榮 B part. Aqueous bromine. And then what will be the observation for both cases? Yes, I can see some of you who just leave a very good reminder. The color change. Okay, so what is mean by decolonize? Decolonize. Wow.
Decolonize. 1997年 Britain decolonizes Hong Kong.
Hi, 張家榮, what are you studying now? Decolonize. Why? Wait, come on, we are now in chemistry lesson, not some other subjects. Okay? Decolonize. It's not just really wrongly type it something else. So take a look on the color. The color should be yellow or brown to colorless. Okay, yellow to brown or to colorless. So it depends on the reagent to be used. So if you are using organic solvents, okay, it's not yellow to brown to colorless. Okay, so remember that two should match, yellow or brown to colorless. 張家榮, if you don't know how to spell the word decolorize, you may write more words, just like the solution turns from yellow to brown to colorless. Okay, and for those, okay, you are going to write down bromine in organic solvents. what you are looking for is the color change from orange to colorless. And if that two cases, you are referring to the one with having CC double bond. So it is CH2, CH double bond, and then COO, CH3. While you talk about another ester, which is saturated one, the carbon backbone do not have any CC double bond. What I mean is this one, there is no color change. Okay. All right. So this is what I would like to remind all of you. And second, one more challenging questions. It is for project students. I know that you are going to add bromine organic solvent. You know the product. So can I have the product while you use aqueous bromine? Aqueous bromine added to the CC double bond thing. Can I have the product? Do you know how to draw? Apology, you were the one to answer. First one. You know it?
Aqueous.
Yeah, aqueous bromine, aqueous bromine.
Instead of having two bromide, there's one hydroxyl group and one bromide attached to the carbons.
Okay, which position? Something tricky. Then can you get my point? So this
hydroxyl group is negatively charged, so it should be attracted to
carbon 1, 2, carbon where? You count it to the in the middle or what?
To
the one next to the ester group or the terminal carbon?
The one next to the acid group.
Okay, yes, that's right. So this is another version of mechanical group. Okay, so what you have learned in DSE is a simpler version. We focus on the addition of asymmetric hydrogen halide into the CC double bond, which is also asymmetric carbon-carbon double bond, that one, the alkenes by HX. So you may find that the hydrogen atom will add to the place with the carbon atom in a carbon-carbon double bond already having more hydrogen atom. So you may, in this case, you may see that hydrogen will be put here and halogen will be put here. Okay, you use the same concept. And this time we are having bromine water. Bromine water, we have got one chemical inside, which is hyperbromous acid. So we would say it, if you write in equation, we write as HOBr, very similar to HOCl, hyperbromous acid. But this time I shift a little bit because you are going to check the electronegativity of the two. Br is delta plus and O is delta minus, and which is very similar to the case HX. Okay, so OH symbolize X, while Br symbolize H. And then the product will be a little bit different. So we have got CH2. Actually, the HH is here, and then Br here. Okay, and together with that C with the OH here is that, okay, together with COO, CH3. So you may write down something like this. Okay, so of course that one is a little bit out of scope in DSE, but I know some of you who are proceeding to the A-level practice. Okay, A-level practice, and you have to know how to fill in that answer. While the underlying principle is to get to know more about the mechanism of doing the electrophilic addition, right, in organic chemistry. So this is what I would like to leave all of you. to pay attention to. Any questions? Now, if you don't know what is that, don't worry. Don't worry. Just imagine that Br is symbolized hydrogen hydroxy group, symbolize X, and do that and do the same thing. Okay. Thank you. So, how about C? C, we have got propanoic acid and methyl ethanoate. Okay, as I said before, I've just told you a hint on the functional group. Okay. Yep.
Add a sodium carbonate.
Sodium carbonate.
Adds, yes.
Sodium carbonate. You just say a sodium carbonate, right?
All right. Add aqueous sodium carbonate solution to both the reagents.
So remember, for this type of is a as said before, 2 years and 3 years ago in the past paper, the DSE. In the DSE, the markers, once they have got a meeting to argue about the accuracy of the use of these words, you have to add sodium carbonate. Why? Solution. You need to add solution, that word. Why?
Some of the organic acid is anhydrous, so it cannot exhibit its acidic property without water. So aqueous solution of sodium bicarbonate or sodium carbonate is needed to ionize the acid.
So indeed, the carbonate reaction with acid, you need to get to know the particle responsible, right? This is hydrogen ion, okay? And on with the hydrogen ion, we can react with carbonate ion to form carbon dioxide and water. But in that two organic chemicals, they should be without water. But it's rather tricky. Many of you would think of acid, they will always come with water, right? But in the lab, once you were given that chemicals, they are in pure form, okay? No water can be found inside. So what you need to do is to, first of all, you have two methods. One is you add the two chemicals into distilled water first and then add sodium carbonate solid. Or you simply directly add sodium carbonate solution. So whenever you will see the presence of water, this propanoic acid will have a ionization. Okay, will be ionized to form CH3, CH2, COO minus, and hydronium ions if I want to add water to show the change, that the proton transfer. Okay, so after having this, you will have this reaction. The carbonic ions react with hydrogen ions to form CO2 and H2O. Okay, so this is what I would like to remind you. Remember, you are going to add aqueous sodium carbonate, and this is what you have to write it clearly. Okay, solution. Okay, so we have the two cases. The acid, the one with carboxyl group. This is the acid. I've just highlighted this. So we have got colorless gas, bubbles, while the other one is just ester. We would have no observable change. You get the point? Okay, thank you. Thank you. So shall I invite some others to have a try on it? Let me see. Chen Wang. Chen Wang, are you here?
Yeah.
Yep. Let's try D.
I don't really know. Does it can use 2,4-dinitro phenyl hydrazine to test it?
Oh, you want to use 2,4-dinitrophenylhydrazine?
Yeah.
Is it
How do you
possible
plan
that
on
take a
using
look
it?
on the two functional group? Okay, the first one, what is the functional group?
S star is it?
S star. The other one?
Ketone.
Ketone, yeah. So 2,4-dinitrohydrazine is used to test for the presence of carbonyl group. Okay, this is carbonyl group. The one on the right hand side, it is a form of carbonyl group. Right? How about this? So if you write down such, is it a carbonyl group? Is it carbonyl group? Now I know that it's confusing. Why do I say so? Because in your IR, when you study infrared spectrum, it seems that this functional group can be split into two. Okay, in order to tell the absorption peak, right? So you may find this and then this, right? You may find these two separately, and you can tell there is the presence of certain absorption peak and certain wave number. Now, however, if you are going to do the chemical test, you have to consider it the whole thing as a whole. Okay, why? Because the chemical properties originate from this whole group. Okay, so you are going to make this into consideration. While you do 2,4-dinitrophenylhydrazine test, would there be any reaction to the first one? Do you know? The answer is should be no.
I think no.
Yeah?
No.
No.
Because the chemistry doesn't allow the reaction, because there is a slightly negative oxygen next to the CO double bond. So it will be it will repel the nitrogen in the dinitrophenylhydrazine and cannot bind to form white precipitate. Bind to form orange precipitate.
Now, indeed, if you want to get to know the reason for having no reaction, you have to get to know the mechanism, the reaction mechanism. If you don't understand, just make a very simple trick. It is the O, right? That O is delta negative. While it will much affect the whole chemistry about the ester group. Okay, the ester group will be much affected when you compare with this carbonyl group. While this CH3, right? It is just electron donating. It's much different. Okay, so it will much affect the whole chemistry. I don't want to mention too much about the mechanism, just tell you and the role to play about this, okay? The O here is being electronegative. They will affect the whole chemistry, the whole chemical property of this substance when you compare with a ketone. So can you get my point? So the answer is correct. You are going to use 2,4-dinitrophenylhydrazine, while you can produce hydrazone for the latter case, but for the former case, no. Okay, so similarly, you are going to add a few drops of 2,4-dinitrophenylhydrazine. Okay, so you should be prepared to spell the word by yourself. I don't know whether or not all in a sudden in the short questions. What I mean is short questions. You know that the 20-mark questions will have got several subparts. A part, A1, A2, A3, A4, right? We have got, you've been asked about, can you please suggest a chemical, blah, 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 blah. And then the answer is simple. You just write down, you just spell it correctly, you can score that mark. So spelling, please. Okay, so you are going to consider the spelling of this word. And the observation is about the ketone. We have got a red or orange or yellow PPT, while the other one it's just the ester, CH3COO CH3. So they will have no such formation of PBD. Okay? And somebody suggests using Tolen's reagent. Is it possible? Tolen's reagent.
Don't
No.
use Tolen's reagent, because Tolen's reagent will not have a reaction with the ester group, but it won't have a reaction with the ketone as well.
Why not? Why not? Now take a look on this. Okay, the active ingredient found in Tolen's reagent is ammoniacal silver ion. So if you don't want to bother anything about the complex, you just focus on silver ion. Okay, silver ion. The chemical principle is very simple, which is, what is that? It's a type of, what is a type of reaction?
Redox reaction.
Yes, redox. So finally, here comes silver metal, so it forms a silver mirror in the inner surface of the glass container. So what is the hidden message about the organic substances? It can be oxidized. It must be oxidized product can be formed. So that's why, and because of that, you are going to have these aldehyde to make it happen, right? Remember that type of oxidizing agent is not so strong. Okay, it can oxidize aldehydes. Okay, to form what? Do you know what are the oxidized product? Okay, because in alkaline medium, I will write it as carboxylate. Okay, carboxylate. So you may know it as a type of ammonium carboxylate salts, and then silver. Or if you have sodium hydroxide added to it, they may be mixed with sodium ion. So it's mainly carboxylic salt. So I don't want to confuse you. It's carboxylic salt. Okay. Questions? Okay. Remember, it's the type of redox reaction. So we go back to the other two questions. Benzoic acid can be isolated out by liquid extraction from a mixture of methyl benzene. For this one. So I would like to hear some people just like Edmund. Edmund, you did not say anything today.
加個蘇嗰個 Na2CO3 嘅 AQ 落去。
Why?
咁就可以同個 benzoic acid 就 react。
They can react with benzoic acid. Okay, why do we need to react with benzoic acid? Why? What for?
就可以有兩個 layer 咯，一個係organic layer，一個係 liquid aqueous layer。
So you may see the two solvents. Can you see the word two solvents? So you suggest one solvent. What will be the other one? Two solvents.
Calcium chloride.
Calcium chloride. So right. What are they in similar? So calcium chloride and Zhang Gaowing, you say anhydrous. We are talking about solvents. Solvent. So are they different in terms of polarity? Eamon. You get what I mean? So because you see the word liquid extraction, what would we expect to be the to expect in the solution, right, in the separating funnel?
有兩個 layer，一個係
Yes, two
organic
layers. So two layers. So that two solvents should be immiscible in order to have such. Agree?
agree。
但係淺實
Yeah.
但係本身佢個 product 本身已經有 methylbenzene，咁 toluene 本身自己都係一個 solvent 嘅話，咁可唔可以就咁？
So what would we suggest to be the two solvents used? Now maybe some of you think that the mixture of methylbenzene and benzoic acid. So methylbenzene is a liquid. Benzoic acid can dissolve, but I would. Is that anything stated about the relative amount of those two? The answer is no. Relative amount of that two, we do not have any idea. So if the two chemicals is of trace amount, you may expect to be a case having a very thin layer of organic layer in the two immiscible solution. Yeah, good. Some maybe what Punoji said is not wrong. I'm not going to say that he's wrong, but the mixture of methylbenzene and benzoic acid, the amount of it, I don't know. I don't know how much amount of it. And very often that should be a very trace amount. So what should we do about this? So what do you think? Now, so can you get what I mean? In case we have got two layers of considerable amount of solvent there, right? So for the separation, it will be more obvious, right, for you to judge. So, but if the mixture of the organic product is so little, okay, just like 1 ml or 2 ml, that may add with you certain level of difficulty while you do the separating funnel for separation. Can you get my point? All right, now, so what should we do? What should we do next? That means we are going to consider both the we are going to consider the process, right? The possible risk of having any chemical loss. Okay, so both methods they will lead to a chemical loss, but the extent is much different. So if it is just trace amount, very little amount, I do think that according to your observation, you will easily have a great percentage chemical loss. But when you add more organic solvent, is that can you get my point? So you have got two. One is aqueous sodium carbonate. Sodium hydrocarbonate, is it possible? Can I use sodium hydrogen carbonate? Is it possible?
得啊，我覺得可以。
It can also form a salt form of benzoic acid to form what? COO minus. So the purpose of having this is to change to this. So the other one, it is the organic solvent. Excuse me. The organic solvent. So that is immiscible with water. And having that too, can you please give me some example of organic solvent? You cannot just tell any organic solvent that is immiscible with water, right? In your public exam, you need to give me the name.
Dichloromethane.
Dichloromethane.
DCM.
What else? You mean ethoxyethane?
How do you even pronounce that?
Ethoxy, or diethyl ether. So you will say that diethyl ether. So that's the same thing. Okay, ethoxyethane or dichloromethane. So there may be some restricted use of chlorinated solvent nowadays, and as per the recent announcement from EDB, I've just attended one of the seminar, and they try to limit the use. They try to ask the secondary schools to limit the use of chemicals. Okay, in terms of use and also the storage. So you may see less chemicals than before. Once we receive the bubble notice. Maybe you don't know anything about this, right? Something about safety in quotation mark, right? So the organic layer on top, aqueous layer at the bottom. Now, and so what will happen if I put it in organic solvents on top? So we will have methylbenzene, right? That goes with the organic layer. Describe how you can separate. Describe how easy that. There's something about experimental steps. You can 3 bars. So 3 steps. Okay, separate the crude product of benzoic acid using this method. 3 steps. Okay, 3 steps. 陳景熙, oh, you're so silent today. So quiet. It's your turn. 陳景熙.
先得都係講首先加aqueous sodium carbonate solution 先，之後就有constant 嘅 shaking， 之後 while shaking 就 release 嗰個 stopper 就 release the gas build-up。
Are you sure? Release the stopper? Are you sure? Or do you invert it and then open the stopcock to vent the air? Pick one.
It really depends on how you hold the separating funnel. I cannot tell whether or not he's correct or not unless I see the real practical sense. I really don't know. You try it again, tell me.
加完 aqueous sodium carbonate solution 之後，就一輪 shaking 之後咧，就將佢擺翻一個 upright 嘅 position， 再開 stopper release 個 gas build up。
Yeah.
之後就 allow the 2 layers to separate into 2 layers. The top one should be the organic layer, while the bottom one should be aqueous layer. We open the cork and release the aqueous layer.
Aqueous layer. Okay, and then? And then? 冇啦。即係倒翻 aqueous solution 就得啦。嗱 with the crude product of benzoic acid, because you have added sodium carbonate solution inside that, what will be the form of a benzoic acid? Is it still benzoic acid?
No, it contains some water. Maybe.
It's sodium benzoate.
Yes, it is benzoate. Except before you may see that the form it is now benzoate ion, but not benzoic acid.
To obtain the benzoic acid, we need to displace the we need to displace it with a stronger acid, for example, hydrochloric acid, and
Hydroxide.
form sodium chloride and benzoic acid.
Okay, to add sodium add together with the sodium benzoate, right? To transform back to benzoic acid, right? So once I have got these, the benzoic acid, but we have got an aqueous solution, and then we generate the form of our benzoic acid. So what will be the stage of benzoic acid? Is it a liquid? Is it still in a liquid form? So what you should do the next procedure. So what is that?
Dry it.
It is in form of what? Do you know it? So what will be the form? It's in form of a solid, right? So what should be done next? Is to collect it. Okay, we are going to collect the benzoic acid by filtration. Okay, benzoic acid. You are going to collect it by filtration. Questions? Why is it in form of, yes, why is it in form of a solid? Good question. Trần Kỳ Hy asked, why is it in form of solid, in form of PPT? He said it's PPT. Now, in case benzoic acid is soluble in many organic solvent, but for the aqueous solution, try to take a look on the solubility in water. At 25 degrees for 1 liter of water, 1 liter of water, the solubility is 3.44 grams. But if you want to have a fair comparison, normally we use 100 milliliter of water as a comparison point, right? So it will be divided by 10. Here comes 0.3 gram at 25 degrees. So very, very low solubility. And you may treat the benzoic ion and benzoic acid is at equilibrium as well. So you add acid, a larger amount of acid to it, it will have a shifting in equilibrium. Okay, so normally the treatment should be, I would like to add excess the acid to it, such that the equilibrium, all of them, they will shift towards the benzoic acid side, such that we can collect the benzoic acid as much as possible. Okay, so the tricks will be this. Okay, if you add more acid, mineral acid to it, you may you may see a chance of having something not soluble. The more acid you add, the more PPT will reform, and further add until no more PPT will reform. Can you get my point? And then do the filtration. By doing so, you can collect most of the benzoic acid. So I know that it will be quite hard to always talk about it without doing any experiments. So we would have I'm now arranging some experiments to be done, but while we meet. Okay, so we will have a after school supplementary lessons, just like what we have in May. Okay, long for it. Better than such, I must tell. Now, yes.
我想問，如果 用 sodium hydroxide，跟住再用 acetone 做個 solvent 嘅話得唔得㗎？
Sodium hydroxide. Now, if you use sodium hydroxide, so what you're looking for? Steel benzoate, right?
Yes.
And then what's next? Now,
I
now
use
acetone.
acetone.
Yeah, now acetone. It is. But do you know the miscibility of acetone and aqueous solution?
In normal condition, acetone is miscible with water, but it is immiscible with sodium hydroxide solution, concentrated sodium hydroxide solution.
So that may be something rather confusing if you did not state it very, very clearly about the use of the chemicals, and because for the acetone, you may see certain type of miscibility with water. And what's next is about the use of sodium hydroxide. What you just mentioned about the concentration is rather high, is it?
Yes.
So when you compare the use of carbonate, hydrogen carbonate, and NaOH, I do think carbonate or hydrogen carbonate would be a better choice. Okay. Of course, you may use an NaOH, but maybe I suggest you to change another organic solvent, right? Because acetone is a case in which it is rather soluble in aqueous medium. Can you get my point? So you may either use NaOH together with another organic solvent.
Okay.
I do think it would be better. And if you do so, no need to make it concentrated, right? No need to make NaOH concentrated. You can make it aqueous and dilute aqueous and then do the boiling process. But be aware of the next step. While you use NaOH, I would predict you to have quite large amount in excess of it. So what will happen next is to do the neutralization process to regenerate the benzoic acid that you may unavoidably add more mineral acid, right, in order to regenerate the benzoic acid. So this is another issue, right? Something about the use of chemicals. Okay. Theoretically, you can do a lot that there will be a ways of chemical, and you may think of some safer and also more economical method. Okay. Questions? C. The crude product formed in a valve setup contains some impurities. How can the crude product be purified? How? Can I have somebody? Zhang Huanwei, are you here? Zhang Huanwei. Yep, recrystallization. So nice that we've got 1 mark. So you may write down recrystallization that. But if you are asked to give me the steps in terms of 2 or 3 marks, can you manage? Do you still remember you have to do such as well? 蔡仲祥. If you are asked to really write down the steps, I know that in this questions no need, just 1 mark. But if you see the marks as 2 to 3 marks, so what should be you are expected to write the steps, right? No. dissolve in acetone, dissolve in minimal amount of hot solvent, right? And then what's next? First step. Again, what's next? Filter the hot mixture. If the filtrate to cool down room temperature are allowed to cool slowly. Now, I don't know whether or not the solution will contain other solid impurities, right, while you have make the dissolution. Okay. So if there is, you have to filter. If not, just leave the solution to cool down to room temperature and let crystals form. And then 3. Yep, and then you are going to collect the crystals by what? Filtration. So you are going to wash it, dry it, etc. Right? Appropriately. So this is the general steps of doing such. Okay. So is using hot water possible? Yeah. Okay. You may use hot water because hot water will have a much difference in solubility while you compare with the water at room temperature. Question 2. We have got this. So whatever chemicals that will be given, please spot for the functional group because more or less they would affect some of the properties. So for TLCs, you may know something about the polarity of a substance, right? So it's analyzed using thin layer chromatography. Okay, given that it's this system, the stationary phase is non-polar, while the polar phase, mobile phase is polar. So this is another information that you need to pay much attention to, right? So the results were shown below. Calculate the RF value was for A is easy, right? Is warm up questions. Calculate the RF value. What we get is about
What?
Yeah, I will see
okay?
53.5. The solvent traveled through at the distance 53.5, is it?
Oh my god. It actually
front.
went out of the paper.
Come on. The TLC is TLC, the thin layer. So what is thin layer? Thin layer is a glass plate, okay, with some white powder coating. Okay, some white powder coating. So while the white powder coating is a place where to place the dots, so the answer should be less than 50 millimeter. you are going to measure solvent flux, okay? You are going to measure the solvent flux instead. So what is it? Yeah, so you are going to get rid of, just like what Wang Zhou has been saying, you have to get rid of the starting line. We've got 4 mm, 4.0 mm, and then solvent flux nearly the edge, at the top minus 2.5. A rather tricky one, right? It is the solvent flux, distance of the solvent flux. And what is the spot travel? What has it traveled? About 9.5 mm. So what is that? 0.218, is it? About 0.2. Yep. If you are having a two, just two. Second is 0.22. Okay, is that clear? Now, suggest which compound is present in spot A. Spot A, what is that? Spot A, the one which is more likely to be absorbed by the stationary phase. Okay, so what can it be? Wang Zhou. Wang Zhou, what do you think? What would be the charge? You have got multiple charge, right? A, B, C, D, W, X, Y, Z. So what is that? Why? Compound W, why? Explain the answer. Can you suggest some structural features of this, of compound W, when you compare with other three? Why? Less polar? Yep. Or non-polar? Yes, that's right. If you have talked about it's also possible. It contains no polar group. Contains no polar groups. Okay, so you are going to explain. So once because of that, what does it tell? It will be more what? There will be absorb more ready to the non-polar stationary phase. Okay. C. That's part 3. What should the compound be present in spot D? Another extreme, spot D. Spot D. Who haven't answered anything? Mặc Kiều Lam.
Hi.
Spot D. What can be spot D? Spot D travels the greatest distance. So amount W, X, Y, Z. What can it be? Hi, Mặc Kiều Lam. But come on, it's not just say a greeting and turn on the mic, you have to answer. Or you always say, I don't know, and you may get rid of being asked anymore. Why is it to turn it in reverse, right? Simply because you don't know, you have to learn more. Now take a look on the previous question, right? The one which is more likely to be absorbed to the stationary phase is non-polar. How about going in reverse? You're looking for what? The substance which is the most polar one. Yes, that's right. Why? Why is why? Reason. Why is why? Yes, most polar. Why? Because it contains the most polar, a sense of comparison, remember? The most polar what group? How do I call that group? COOH group, what is that? CAR. You don't know? Carbox. Check spelling, please. Carboxyl group. Okay, the most polar carboxyl group. Okay, so which is the most soluble in the polar solvent? So it travels the greatest distance. Or you tell me they have got the highest RF value. Okay. B, suggest a method to obtain the pure compound sample of P and pure sample of D from this mixture. What should I do next after doing the TLC? Obtain a pure PA and D. This is something about separation method, right? How will you separate it for values?
Column
Yes,
chromatography.
column. Yes, that's right. Column chromatography. You are going to run the column chromatography, and then you are going to check which one comes out first. A, B, C, D. Which one comes out first? Column chromatography.
Y. D comes out first. So probably Y.
Okay, D.
The chemical in spot D comes out first, yes.
D spot, and then go to A, right? The steps will be this. So the first chemical that come out is spot D, and then I don't know whether or not the other unknown spots in the middle, and then finally here comes spot A. So you may find it here. Okay, so you may find Y comes out first, and then W, right? You're going to do it in reverse. Okay, this time while running column chromatography with what? That is the key, right? With a solvent, which is the same. Is it the same solvent as the TLC? Right, same solvent as TLC, and you do it again. And we may do the similar outcome, okay, which is the one which travels with the solvent will come out first, and based on the polarity. Do you understand? Do you understand the whole thing? Now, just a reminder of this chapter. You need to know how to distinguish the two organic substances with one another. You may be, if that is the case, this is maybe 2 mark questions. or maybe simply or even just 1 mark if it is a very short response questions. What I mean is in part A. Okay, part A, very short response questions, or this concept will be embedded together with the question asking for IR, MS. Can you get my point? So for the first part, for the organic chemistry part, it's not that difficult. So what you need to spot out is the functional group, the difference in the functional group. If you can spot the difference, you may choose the appropriate chemical to make such distinguishing process. Can you get a point? This is the point 1 about this. Second, the remaining parts we may see TLC or column chromatography, paper chromatography, all those they are just talk about chromatography. Okay, chromatography, and this is one type of separation method, and separating funnel is another the common separating method that you need to know. So simply speaking, to end to conclude the lesson today, so we have got the QA for organic chemistry, usually that may cross over with the questions IRMS. We have got a integrated method, and together with some questions about the separation method. So the heat topic, right? Very hot topic would be what I said before, something like separating funnel, and what else? Hot chromatography. That too is of quite frequently asked. Okay, it's quite frequently asked. Of course, you may get prepared to think of distillation, fractional distillation, etc. But those they are of less importance. Okay, if you want to compare with these two, SAP1 chromatography. Questions? Would it feel better? Do you feel better? We have got a very in-depth coverage of this exercise. It's not just a merely answer, but also I would like to ask you why. And I do hope it will give you a great recall of your memory to tackle that problem. And I would like to find some people who score into different extent. I will give you different comments based on your score on your 真公报 exam. And I would like you guys to, I would like to ask you to proceed to some other thing else. In short, more learning opportunities coming. Okay, pencil. Are you ready for such? Yeah. Not ready, but okay. You are forced to say okay this time. You're forced to say ready. Zhang Gawen, where are you? What is means by NOK? Huh? More learning opportunities, or you have to chase those missing learning opportunities first before you'll be given more learning opportunities. Okay, don't worry, Mansil. More will come. Goodbye.